And I can start with introducing the next briefing partner who dealt or is dealing, we're gonna be explained about that, with trains, mostly with trains, and they put up a lot of challenges actually. It's the company named Alstom and represented by Florian Gombots and György Jenai, who I think is not with us today. That's fine. And Florian will explain to us what the challenge was and hopefully then call your teams who worked on the solutions.
Thank you very much. Sorry, can you hear me now? Yes.
Yes.
We had 3 challenges. We're Alstom, we're a train manufacturer and manufacture trams.
Mike has to go close to the mic.
Sorry.
No worries.
Okay. We had 3 challenges. The first one was a person detection in, on and around trains to secure space and safeguarding space. The second one was prediction of battery lifetime. We're using a lot of batteries in our trams, and we still want to know how long will it last, the battery, before it will go, be defect. And the third one was vibration management. Vibration measuring to measure vibrations on gearboxes and motors for easier failure detection and reduced downtime. 2 of them were taken, 2 challenges were taken. So I call for the first company, BatteryCheck, to present their solution.
And we welcome on stage Michal Šaštinský. I hope I pronounced this correctly. Hi, Michal.
Hello.
Trying to get your slides up. Help me out. Which one?
Orange.
Not opened. Okay, let me see. It's here. Okay. Doesn't open.
Okay, I'll be looking at that one.
Ah, it's okay.
Is this the clicker
Yeah,
I can use?
this is the clicker you can use. Yes, please.
Okay, it's not a problem of the battery, but it's a problem of the PowerPoint. Can you please raise the hand if you struggle with the battery unpredictability, for example, with your mobile phone? Everybody, so you know what I'm going to talk about today. Batteries are everywhere. You see them in your private life, in the business, in manufacturing. They are powering a lot of critical systems, or pleasure, or freestyle, or basically the systems which are producing whatever we are using in our real life. And we don't have one-size-fits-all batteries, so we have different sizes, different chemistries, different use cases, and that is creating a tension, because batteries don't like the stress, and they are failing, catching fire, explode, then there is a lower performance, and it has very often very negative consequences on the performance, reliability, safety, and very often there is also regulation coming. Who we are BatteryCheck, sitting in Bratislava. We are a software technological company providing predictive battery monitoring and analytics solution to manufacturers and service providers. We already have 3 patents, 2 awards, and we are kind of like a Google Analytics for batteries, so you can understand what might happen into the future. Florian already introduced Alstom, but I didn't know, whether I should repeat it. I just found out that you will be 100-year-old company within 2 years, which is impressive. And they are producing metros, trains, like TGV in France, or trams, and basically everything around logistics. And they do have a lot of batteries, surprisingly, not only in the trams and trains, but also signaling, critical infrastructure, their own buildings and manufacturing sites. So there is a lot of areas for the cooperation, but we were part of the challenge for the trains, and that's basically what we discussed with Florian and György, who is not here today. So basically, to describe what it is, you have a train, It has batteries, which are powering up a lot of interesting systems. And if the main electricity is not working, batteries are coming, and they should be healthy enough to provide a service which they are supposed to provide. So basically, we need to connect completely offline and disconnected batteries somehow and get the data. So that's basically as easy as it is. And if you know what is a parallel slalom, which we are in Austria, I used to be a downhill racer when I was young and handsome. We were discussing the use case that we will go two streams. The first one is that we will discuss what we can legal and regulatory put onto the train, because I mean this is highly regulated area, so we should comply with certain regulations for the hardware, software, cybersecurity, and yada yada. And on the other hand, we will do IKEA. You know IKEA? We will create our own data, so we are not waiting for the regulatory guys to give us a permission to install something onto the train. And this is what we've been discussed, and it's very interesting. So basically, we will leverage our hardware and sensors, which are measuring current voltage and temperature. We generate the battery telemetry measurements. Then we will ingest those telemetry measurements into our platform. We'll run our magic, and then provide alerts, recommendations, and predictions which are necessary for the use case of the Alstom. If we go really technical, we will do anomaly detection, machine learning, and other predictions in order for operators or even the owner or the personnel to understand if the battery might fail, when, what to do in case of predictive maintenance, procurement of the new batteries, replacements. So basically, on a software analytical level, we are covering the whole life cycle of the batteries in Alstom. And then, I mean, you can see everything in the portal and see what is happening. I mean, we can also push it up to WhatsApp, because I don't know if you know, but WhatsApp is the most critical enterprise tool among a lot of corporations. Very often it's called shadow economy, but that's how it is. And especially service people, they are not very often behind the computer, so all the portals and the nice tools are useless, but if they get an alert onto the WhatsApp on their mobile phone, they can react very quickly, maybe even get the personnel out of the train or tram, because there might be a bigger problem. You clicked anything, or the battery is
Possibly.
Okay.
Can you try again?
Try again. Okay. And in that case, Alstom can have a look at all those trams and metros and other vehicles as a kind of a fleet and understand where they might be a problem, or it just needs the proper maintenance, and based on that react, because reaction is always very critical. And it's not that only we can work on this use case, but also provide the benefits in case of safety, performance, asset value, and compliance, because as mentioned, this is a highly regulated area. And that's everything from my side. Thank you very much.
Thank you. Second team, please, onto the stage. Lukas Kirmann, Markus Fink, Toni Inurean, Henry Pfeiffer and Ahmad Alsayad. Where are you? One person is joining us on stage. Not here, I fear. Wait, let me. Just close. No, I don't have it. I can try. Just give me a second.
So, hello everyone. First time that I'm speaking with a microphone in an audience like this. And it's an interesting happening here. And I'm sure...
I can click for you if that's okay. Can you see it?
Yeah, when I
Okay,
change the
good.
paper, you can
Yes.
change the size.
Yes, no worries.
Okay, thank you. So, we are not a big company. We are just 5 students working on this challenge. So, welcome everyone here in Vienna. Today we present our solution to a real industrial challenge by Alstom. We try to reduce technical failures in train systems, tram systems, not train. Okay. So, imagine you are in a tram on the way to the Rathaus, just to here, and suddenly the tram stopped. And not only the tram stopped, no, also all the traffic behind and all the trams behind this tram also stopped. And it takes about maybe up to 1 hour to remove this tram. So you can imagine this is quite a big problem if this happens. So the reason of this is often a failure of the gearbox system. Even if a tram does not have gears like a car, it still contains a complex gearbox system. Inside, there are hundreds of moving parts, and they operate under high pressure, especially when the tram starts to move. So our solution is a condition monitoring system. We place vibration sensors at key positions on the gearbox and on the motor, so we can measure the system behavior at all time. The key is the vibration and frequency analysis. Every component has its own frequency, and when a component is damaged, the frequency changes in position and amplitude. So with this analysis, we can see all the moving parts. We can see if there's a difference in the frequency and the amplitude, and so we can know what kind of damage we have. And with some training loops, we can also say how long will last this part. So we can just say when the tram has to go to the repair station. Due to the limit time, we were not able to test this in real situation. Therefore, we developed a simulation environment to test different failure scenarios. From everything is okay till there's already a damage on the gear. We also considered different users of the system. An expert needs full technical insight, a mechanic needs to know which part is defective, the driver needs to know how long he can go on, and the passenger just wants to know if he's right on time. So, thank you very much for your attention, and we are happy to answer your questions afterwards.
Thank you very much. That was the team of the University of Applied Science.
My team.
Where is the team? Oh, there is a team as well. Come on, guys. Get up on stage together with Florian and with Michal, please. And make sure you get one of these beautiful Emmys, our Emmys, as a trophy for your contribution. Thank you very much.
Thank you, gentlemen, and congratulations on this very interesting solution.